Today I'll talk about psychrometric chart. I'll discuss how to understand and read a psychrometric chart. Now here I am giving one psychrometric chart. You know, a psychrometric chart is a graph that shows the thermodynamic properties of a moist air at a constant pressure. It is a standard tool used to HVAC industry to visualize the relationship between dry air, moisture and energy. Today, engineers and scientists use psychrometric chart to see how gases and vapor relates. Though this chart might seem complicated, they are easy to read when you know what each part means. By finding the axis and reading the chart marking, you can mark point and draw the conclusion from the known measurement. Now I already put one psychrometric chart, and this chart shows the relationship between dry bulb temperature, wet bulb temperature, humidity ratio, relative humidity, dew point temperature, enthalpy of the mixture and specific volume. So the chart can be used to quickly characterize the relationship between these 7 air properties at different conditions. So now here the 7 properties: dry bulb temperature, wet bulb temperature, humidity ratio, relative humidity, dew point temperature, enthalpy of the mixture and specific volume. These are the 7 air properties. Now if you know any 2 properties, so you can find out, you can easily find another 5 properties. Now I'll show you how to read the psychrometric chart, and then I'll take one example, and then I'll show you how to find out other air properties if any 2 properties are given. Now first read the psychrometric chart, means how to read the psychrometric chart I'm going to explain. So here I'm putting one blank psychrometric chart, and this is the psychrometric chart area. Now if you look at the bottom, or that x-axis, so this x-axis actually represent dry bulb temperature. Generally dry bulb temperature is given in degree centigrade or degree Fahrenheit. So this is the dry bulb temperature, means x-axis represent dry bulb temperature. And each, now here you can see that vertical line is coming from x-axis. So each vertical line actually represent dry bulb temperature. Now if you look at the right hand side, that right hand side represent the absolute humidity, so that is kg per kg dry air. Now here also many horizontal line is coming from that y-axis, so each horizontal red line represent the absolute humidity. Now here here you can see that many curved lines actually present in that psychrometric chart. So each curved line is represent relative humidity, that is a relative humidity. So now here 10% relative humidity, 20%, and this in that the end, so that is that closing of the psychrometric chart. So this solid line is, that is 100% that relative humidity. So that relative humidity is called saturated curve or saturated line or saturation curve. So now this curve is the relative humidity and this represents saturation curve. Now in this psychrometric chart, this diagonal line, if you see this diagonal line represent the wet bulb temperature. So if you want to know the wet bulb temperature, so you must see this horizontal line, diagonal line. So in that diagonal line represent wet bulb temperature. So now another type of psychrometric chart, means this type of psychrometric chart. So again this line, this again this diagonal line or this line actually represent the specific air volume. Now this type of psychrometric chart, again this diagonal line represent the enthalpy. So if we want to calculate the enthalpy, so we can use this type of psychrometric chart. Now here, now I am taking one problem. So this problem is that dry bulb temperature and humidity is given. Now we have to find out wet bulb temperature, relative humidity, dew point temperature, enthalpy of the mixture and specific volume. So now here the 2 properties are given, that is dry bulb temperature and humidity. We have to find out that 5 properties, that is wet bulb temperature, relative humidity, dew point temperature, enthalpy of the mixture, and specific volume. Now this is the psychrometric chart. Earlier I discussed that right hand side y-axis represent the absolute humidity, and that horizontal axis or x-axis, that is represent that dry bulb temperature. Now here dry bulb temperature is given, that is 27 degrees centigrade. Now if you see here, so that is the 27 degree. So from here we draw the vertical line, and humidity is given, so that is 0.015. okay, so now these 2 points cross each other, so that is the common point. So from this common point we have to find out all other 5 properties. Now first we are going to find out wet bulb temperature. Now here each that line, red line, this line, this line, this line, represent wet bulb temperature. Now from here we are I'm going to just draw one that parallel line of this red line. So that will cut this curve line. So from this curve line, so that will intersect here. So that is nothing but the wet bulb temperature. Or if we draw from here to in that downside, means if I go from here to in the bottom, so if I draw that, so that will give the wet bulb temperature. So that is near about 22 degrees something centigrade. Now next I have to find out the relative humidity. So relative humidity, that is wet bulb temperature. So now here we can easily find out the relative humidity. So now you can see, so this line represent the relative humidity. Now it is passed through something like that here. So from here we can easily find out what will be the relative humidity. So relative humidity maybe 68 point something percentage. Next we have to calculate the dew point. So for this dew point we have all this common point. So from this common point we draw the horizontal line, and then that will cut that 100% saturation line, means saturation curve that will cut here. Okay, so from that if we go down, so that will cut the x-axis, so that will nothing but the dew point temperature. So that is nearly about 20 point something. Now next we are going to calculate we are going to calculate the enthalpy of the mixture. So now now here the specific volume first. So now this is the common point on this dry bulb temperature and humidity. So and this line represent the air volume. So if I draw from here to here, so we can find that we can tell what will be the specific air volume, so that we can easily get that. Now next this type of that psychrometric chart. So this that red line represent the enthalpy. Now this is the common point, dry bulb temperature and humidity, so that will cross each other. So from here if I draw that parallel of this red line, so from that we can easily calculate what will be the enthalpy of the air. So now if we do like that, so ultimately for given dry bulb temperature, here given dry bulb temperature 27 degrees centigrade and humidity 0.15 kg per kg dry air, so we can easily get, so this is the dry bulb temperature and absolute humidity is given. So from this psychrometric chart we can find, I already showed you that how to calculate relative humidity, then air volume, enthalpy, dew point, and wet bulb temperature. And as we know that absolute humidity, from that we can calculate the vapor pressure of the water, so we can calculate that things also. Now so this is the type of psychrometric chart. Now in that undergraduate level, so here is the another type of psychrometric chart. In this psychrometric chart, if you see here in that the bottom, so this represent dry bulb temperature, this is that relative humidity is given, absolute humidity, the kg of water vapor per kg of dry air, and then this line is the enthalpy of dry air, this line is the specific volume of the dry air, this line saturated humid volume, this line enthalpy of the saturated air, and this that left hand side, this scale means y axis is nothing but enthalpy of kg per kg of dry air, and also another axis given, the VH, humid volume meter cube per kg dry air. Here that H dash, enthalpy of kg or kg dry air. Here this line is nothing but adiabatic saturation curve, and this curve line is that relative humidity, and this is the 100% humidity. These are given. So this is another type of psychrometric chart. Everything is given. Now I'm taking and this red line. So this is dry temperature and this is that absolute humidity. Now from here I'm going to find that as that two properties of the air is given, that is dry bulb temperature 25 degree centigrade, that is 25 degree centigrade dry bulb temperature is given, and humidity is given, that is 0.015 kg dry air, kg per kg dry air. Now using this psychrometric chart I'm going to calculate, I'm going to find the white bulb temperature, relative humidity, dew point temperature, specific volume, enthalpy of the mixture. So I'm going one by one. Now first I'm just mark the dry bulb temperature. So this is dry bulb temperature here, that is 27 degree. So this is 20, okay, so 22, 24, 26 and 28, 30. So this is 27, okay, and humidity is given, so that is 0. So this point 0.015. Now I can draw that horizontal line, so that is humidity 0.05, and we got that common point. So after getting that common point, so first we are going to calculate wet bulb temperature. So for this wet bulb temperature, so we have to draw that the horizontal line, so adiabatic saturation curve, so that will cut that saturation line. So if I draw that parallel line of this adiabatic saturation curve, so that will cross here, okay, and that is nothing but wet bulb temperature. So now here you can again, so we have to draw the parallel line, and that will cut the 100% saturation line, and from there we can easily get what will be the wet bulb temperature. Okay, now next we have to calculate that relative humidity. So relative humidity we can easily calculate, because here, so this is something like, this is 70% and this is something 80%. So in between 70 and 80%, so 77 or something, the relative humidity. Now next we are going to calculate the dew point temperature. So from we got the common point, and then we draw the we have the common point, so then we draw that horizontal line, and it will extend to that saturation curve. So if I do that, and then so that will cut this point, okay. So now if I come here, so that will give the dew point temperature. Next that is dew point temperature, nearly something 22 point something. Next I'm going to calculate the enthalpy. Okay, now here, so this is the humidity is 0.015. now I'm just extend the dry bulb temperature to the enthalpy of saturated air. So this is an enthalpy of the saturated air. Another is this line, so this line is enthalpy of dry air. So now this dry bulb temperature curve that is intersect 2 points. So this is the 1 point, another is, this is the another point. Now in these 2 points, so now from here, so that 1 point, so that will intersect 100% humidity. So from as this is intersect 100% humidity, from here if we draw that horizontal line, so we can easily calculate what will be the 100% saturation humidity, 100% absolute humidity. Okay, so what will be the absolute humidity for 100% saturation? Okay, after getting saturation humidity we will get that saturation humidity is nothing but 0.023 kg per kg dry air. Now so here we got 2 points, one is enthalpy of dry air, another is enthalpy of the saturated air. So enthalpy of dry air, so that will nothing but 28.5 kilojoule per kg dry air. Now if I draw that horizontal line, so that is enthalpy of enthalpy kg by kg dry air, so that is 28.5 kilojoule per kg dry air. Another is cutting, so that is that enthalpy of saturated air. From here we can easily get the enthalpies, that is 84 kilojoule per kg of dry air. So we got that 2 point. From that 2 point, if we do interpolation, we can easily get the enthalpy of the mixture. So enthalpy of the mixture, so that enthalpy of dry air plus the interpolation, so enthalpy of that that saturated air minus enthalpy of dry air into that humidity of that air by saturation humidity. If I do that, we will get the enthalpy of the mixture is 64.7 kilojoule per kg dry air. Now if I going to calculate the specific volume, so again, so this is the saturated humid volume, so this line. Okay, another is here that specific volume of the dry air. Okay, so from that we can easily calculate what will be the specific volume of the air, so by interpolation. So now here again we know the saturation humidity, and this point cut, that is the specific volume of the dry air, because we are extend that dry bulb temperature line. Another is so that is, so this point the specific humid volume is 0.86, because here it is given. Okay, so this is specific humid volume, so this is nothing but 0.86 meter cube per kg dry air. Now another point that will cut, so that will give the specific humid volume, so that is nothing but 0.88 meter cube per kg dry air. Okay, so now we can interpolate and we will get the specific humid volume. So specific humid volume, so that is kg per dry air. Okay, so this one specific humid volume 0.86 the dry air humid volume plus the interpolation plus 0.88 is that humid volume of the that saturated air minus again dry air into 0.15 by 0. Saturation humidity. So if we do the calculation, we will get specific humidity is 0.873 meter cube kg per dry air. Now next I will calculate so the humid heat. So the humid heat actually definition is already given, so that is 1.005 means dry air humid heat and plus whatever water vapor is there, that humid heat. So 1.005 plus 1.88 y dash means absolute humidity. So now we can put that 1.005 plus 1.88 into 0.015. So if we do the calculation, we will get humidity is 1.033 kilojoule per kg dry air. I hope you understood how to get all the properties of air from the psychrometric chart. Remember, if you know 2 properties of air, you can easily find out another 5 properties. In psychrometric chart, that 7 properties are actually given. So if you know 2 properties, other 5 properties you can easily get from the psychrometric chart. That's it. Thank you.